Okay, great. So hey everyone, my name's Alan Hickey. I'm a data scientist here at Coursera. I've worked here for, I guess it'll be 3 years at the end of the summer. It's been a good amount of time, and I work mainly on learning analytics, which for us essentially means uh, we split it up between sort of growth analytics, which are making sure that learners get into the right courses for them. And then learning analytics is once learners are in courses, we're trying to make sure that they're getting the most out of them as possible. So boosting completion rates or, building more personalized learning experiences all sort of fall under that domain. Um, so I figured it would be best for me to start by answering these the pre-submitted questions that we had. So I'm going to go ahead and share some like brief slides. Let's see. Great. Um, okay, cool. Just sort of going through most of the questions that you guys had for me, and then I can talk more about my background sort of as we go, because a lot of the questions were sort of about how to get into data science and some tips for both on the job and finding a job. So sort of my agenda, I sort of broke up the pre-submitted questions into like three main categories. The first is like career trajectory for data scientists, and I can talk on that, and I'll focus specifically on, is there a best area of study for undergraduate students looking to get into data science? And I'll also talk about moving from other roles into data science and how sort of prevalent that is. Secondly, there's sort of questions about job hunting tips. So I will specifically focus on like how someone might move from being, a Coursera learner with a, different non-data science background, moving to become a data scientist, and also talk about some interview tips and specifically how to focus on, the problem solving that a lot of data science interviews focus on. Thirdly, I'll talk a little bit about some of the lessons on the job that I've learned. This is my first full-time data science job. I interned at Facebook for one summer before I started at Coursera, but certainly there's been a steep learning curve, and I've learned a ton over the past few years. So I'd love to share some of those insights. And then after that, I'll sort of open it up to any questions that live people have. So go ahead and add those to the chat, and then we can get to those at the end. Okay, great. So the first topic is sort of like this career trajectory for data scientists, and here are some of the pre-submitted questions that were, sort of within this topic. So it's possible some of you may have seen some of similar slides from my colleague Vinod, who did a webinar about a year ago, but I think this is a good sort of review. So the first question when talking about sort of what is the career trajectory for the data scientist is really understanding what a data scientist is and what data scientists do. So probably the pop culture definition for a data scientist is, someone who's better at statistics than any software engineer and better at software engineering than any statistician. So this is like, kind of like funny and anecdotal, and to some extent it can be true for certain people, but it doesn't really get at what data scientists actually do. Data science has become, so popular over the last few years that actually, Google has the automated definition ready. And this definition, I think, gets a little bit closer. So a person employed to analyze and interpret complex digital data, such as usage statistics of a website, especially in order to assist a business in its decision-making. So that's closer, and it talks about, a lot of sort of the key aspects of being a data scientist, like interpreting a lot of data and driving it towards business decision making. But really, when I think about data science, I actually think about two sort of distinct flavors of data science. So the first you can sum up as sort of a decision scientist, and this is what we call it internally. So a decision scientist is someone who focuses on actually driving like business decisions within the company. So these are people that work closely with product managers or other sort of business leaders to help understand like which strategic decisions should the company make. And this is less about, necessarily like building things that go into production, and more about running exploratory analyses so that product managers are well informed, helping decide which areas of the product like a company should focus on, understanding the impact of new features that we launch, with experimental design and analyzing A/B tests. So that's sort of the main sort of drives behind a decision scientist. Separately, there's another flavor of data science that is more aligned with machine learning engineering or data products. So these are people who are closer to sort of engineers than they are to like product leadership. So you'll find yourself working more often with like backend engineers to like hook up the outputs of some machine learning model to live like in production services. And these people tend to be a little more focused on engineering and like machine learning and writing, spending most of their time actually building things rather than necessarily trying to understand and communicate results as much. So sort of a diagram to show these two different types of data scientists. So we can see like most data at most, non like super early startup places will live in like a nice sort of data warehouse, which is managed by sort of like data infrastructure engineers or business intelligence engineers that help sort of structure the data. And then with that structured data, decision scientists try to drive towards business decisions and help leaders within the company decide what we should be working on and how we can build that. And machine learning engineers focus on instilling algorithms into the product that allow the company to benefit from sort of the scale of its data. And examples of sort of data products like that you might have seen in your everyday life, or like anytime Amazon gives you a recommended product, that's a data product. Anytime you search for something on hotels.com or something like that, and you see sort of a recommendation for which hotel you should go for, that search ranking algorithm is a data product. Anytime you look at customer reviews and understanding like what are the main sort of features of customer reviews, that's a data product that more of a machine learning engineer would work on. But both of these types of data scientists really are focused on taking data from a structured place where, but there's a whole ton of it and it's really hard to understand, and turning it into business value. So the skills that you need to be a data scientist, it's actually really, really broad. And in general, data science is more of a broad than a deep domain. So like listed here are sort of like the broad-based skills that almost every data scientist typically has. So, there's sort of table stakes stuff like, math and statistics, which are super important, especially for, like being able to understand complex data and, make sure that we're driving important results from it. There's programming. The majority of databases are going to be accessed with SQL, and then like most data scientists use R or Python to sort of then analyze the data further, build models, etc. There's machine learning, which is essentially like building models, but then having a feedback loop within the product so that the models continue to get sort of smarter and smarter. And then there's a lot of like business and product intuition. So communication is a huge aspect of data science that I'll get into more in depth later. But understanding like what the business is trying to do, and being able to define metrics and communicate the results of analyses to a non-technical audience are really, really important skills. So as I think about some of the pre-submitted questions, one of them was sort of like, hey, like what undergraduate major is really best for me to study. So I think a lot of that depends on like what kind of data scientist you want to be. like at Coursera, most of our data scientists actually are a combination of decision scientists and machine learning engineers, or data products engineers. But in general, like they are like fairly diverse, and you can find roles that are leaning towards one or the other one. So decision scientists are people who maybe have a statistics or econometrics background, and they're focused on experimentation and sort of business impact. And in general, they should like working with like product managers, business people who aren't necessarily super technical, but you can kind of be that connection between data that is sort of hard for a lot of people to understand, and then like sort of business insights that allow the company to move forward. As a data products engineer, your favorite subject is probably more like computer science or machine learning. And you have to really enjoy like writing a lot of code and putting stuff into production and working with engineers. And you should be more focused on like building things and making things work optimally. Maybe have sort of less of a focus on the communication aspect with sort of less technical members of an organization. So in terms of like which classes are good for someone to take, and these classes come from our master's in computer science and data science from the University of Illinois, which we host here on Coursera. But I think the titles should be pretty representative of the types of classes that you can see in master's or undergraduate programs at a lot of different universities. So for decision science and machine learning engineers, note that there should be like some level of understanding about applications of machine learning, and also methods of applied statistics. These are super important just so that you have some experience with actually leveraging data to like drive a business impact, whether it's in a machine learning algorithm that powers some data product, or in applying statistics towards making decisions and doing sort of causal inference, etc. If you are more interested in sort of the decision sciencey aspect of data science, then it would also be good to sort of beef up your statistics knowledge. So definitely understanding multivariate analysis, or having a good understanding of like econometrics and different kinds of like regressions and models like that, where you're really understanding, doing inference and understanding like why certain numbers look the way they do. It's also good to have a strong understanding of experimental design and A/B testing. There aren't always great courses for that, I don't think, in universities, but there's a lot of great online resources, and I have a link here and I'll share this deck at the end of the webinar. In addition, it's really good to sort of understand causal inference and econometrics. A lot of times, you might make an observation about like, hey, there's some correlation between, this feature being launched and, learners doing this or this, or users doing this or this. And it's really good to understand how, like, taking correlations and trying to make assessments on whether like we can attribute that to a causal impact, or whether like an experiment is necessary. So sort of understanding the statistics and a lot of the applications behind that are really important. On more of the data products engineering, there's a lot more just sort of like standard computer science that someone should probably focus on. If you're really interested in becoming a machine learning engineer, then having a strong background in CS is very, very important. And this is not only just so you learn some of the machine learning techniques, which I think all sort of data scientists should probably understand, but it's also just so that you have experience, writing, creating big projects that are complicated and have a lot of different components, and doing unit testing and understanding that everything works, because you're focused on actually launching things in production. So you need to have sort of that like engineer mindset. So in terms of careers in data, I think it's important to know that like data scientist is not the only sort of like career in data. There was a report from maybe a year and a half ago called Analyzing the Analyzers, in which people ran a bunch of surveys on like current sort of data scientists or people with the role data scientists, and they really understood that. They found that like there are a ton of different like flavors of data scientists, like even more so, more nuanced than like decision science versus machine learning engineer. And people come from a ton of different diverse backgrounds. Like on my team at Coursera, where there's, you know, about 10 data scientists, I know off the top of my head that we have people with backgrounds who, you know, had degrees in math, economics. I studied statistics, physics, computer science, and chemical engineering. So, you know, there's a lot of different things that people might sort of study at an undergraduate level, but making sure that you're sort of working your way towards those skills that I talked about is really the way to like prepare yourself for the job. Specifically, a 2017 study by PwC that I've read before actually showed that, you know, there's 3 times more open positions for data analysts than data scientists. And especially if you're looking for your first job in data science, you'll notice that a lot of the job requirements list like, hey, 3 to 5 years of like data science experience, or, you know, having like a PhD in the field. So it is hard to find sort of those more junior data science roles. But data analyst roles can actually be much, you know, more frequent. In addition, this study also talked about how because like the demand for data scientists is so high, and the requirements that a lot of them ask are so great, companies are actually turning more to internal hiring. So I do think it makes a lot of sense if you're looking to get started in data science to take on a role where you're interacting with data, like a data analyst or a business analyst, but then really continuing to like drive your skills forward in whatever ways that you can, and try to you know, target like a company or an organization where they're going to value like internal development, and, you know, will look internally for hiring data scientists. Certainly a lot of companies are struggling to hire people so directly into those roles. So you know, finding a place where they sort of value like, you know, vertical movement within sort of the data domain is a really good idea. I also wanted to link Harvard Business School blog post that the director of data scientists here, Emily Sands, wrote, which sort of goes into the idea that data skills are vital for a wide range of careers. It's not just data scientists and data analysts, but a ton of people from wide ranging from like, you know, software engineers to, you know, CEOs, like need to understand data, and they're all learning data skills on Coursera. So sort of the bottom line is that regardless of what, you know, career you're starting in, continuing to develop the skills and competencies that line up with your like desired data science career is really, really important. And, you know, having some overlap with data science is certainly a good way if sort of, you know, data science is your sort of final goal. So I would definitely recommend, you know, targeting employers that value internal growth and skill development, and, you know, trying to find roles that do involve some aspect of, you know, the data science skill set. So here's just some like overall tips for, you know, starting a career in data science. The first thing that we talked about was like identifying actually the area of data science that you care about most. So if you're, you know, in school, then tailoring your curriculum to those specific skills. And if you're out of school, I mean, obviously there's resources like Coursera and, you know, other sort of free and open online places to pick up a lot of skills. So it's all about like understanding what exactly do you want to do with your data science career, and then targeting those like specific skills. Another really important tip is to like build a portfolio of applied projects. I'll talk about a little bit about how I did this when I was first getting started in data science. But really the only way to learn a lot of these skills is, not just like, watching videos or like reading up on blog posts, but actually trying it yourself. And being able to talk about and showcase, projects that really do align with what you might do on the job is important. Um, another good thing to note is that don't worry about like picking an area and being stuck there. Certainly, like at Coursera, I have sort of vacillated between like doing a lot of decision science work to working more on data products, and it's actually really nice to be able to keep things fresh. And one of the cool parts of being a data scientist is that you actually get to work on a lot of different projects, which means you work with a lot of different people, and things do stay fresh and really interesting. So kind of find where you think you will be the most interested, at least in the shorter term, work towards that. But definitely don't feel like, you're setting yourself up for an entire career of doing sort of the same type of work. There is a lot of flexibility sort of once you're in the data domain. Okay, so the second topic that I wanted to hit on was sort of like job hunting tips. So the pre-submitted questions we had focused on like, hey, should a person who's taken a few Coursera classes, in the data science domain move forward towards actually finding a job as a data scientist? And then also some question more about sort of interview tips or, preparing for data science interviews or a data science role. Like, are there any tips regarding how to exercise the problem solving and analytical skill set required in data science? So firstly, I want to get back to sort of like this focus on like real world problems and like building a portfolio of projects. So sort of a personal anecdote, the way that I first became interested in data science was actually through sports analytics. And I was super obsessed with a blog that used to be called Advanced NFL Stats. It's by a guy named Brian Burke, who, developed a lot of started applying a lot of statistical techniques to American football analytics. And, he, would create these cool win probability models, and he would use them to, write all these awesome blog posts that had to do with like game strategy and player development and draft strategy, etc. And I, had always been a big sports fan, and I had always really liked math, but I had never thought that there would be sort of a way to combine the two. But I just got really sort of obsessed with his blog, and one of the things that I set out to do was hey, I want to like do something sort of like him. And I was actually able, he works for ESPN now, but while he still had sort of like a really early blog, I actually was able to write him an email and get on a phone call with him and just sort of talk about like what he was thinking. And his advice to me was sort of the same advice that I'm trying to give now. And it's, hey, if you really, think you want to do this kind of stuff, actually try it. Like, look for, inspiration either from, a blog like Brian Burke's, or from the media, or academic papers even. Like, find a topic that you're really interested in that has some like data available to you, and actually try to answer a real world problem or build a real world product off of it. So now there's all sorts of these types of things these days. A lot of you have probably heard of like 538, which does a ton of not just sports analytics, but also a lot of, political science, like pop culture. They do analytics about pretty much everything. And it's really cool to look at that, get some inspiration for a type of question you might want to answer, or even just trying to imitate some of the analysis that you see, and actually getting your hands dirty, building the project will not only give you sort of like a portfolio where, you can link someone to like a GitHub account or a blog post that you wrote that sort of shows that you can really do this stuff. But it'll also just allow you to figure out for yourself, like, hey, is this really the type of thing that I want to spend a ton of hours of my time doing? Is this something that I like talking to about with people? So it'll really help you, I think, not only figure out what you want to do, but also sort of enable you to do that by, being able to signal to possible employers that you're interested and capable. So the first sort of like challenge that I gave myself, just for kind of a concrete example, was essentially trying to mimic some of the win probability models that I had read about Brian Burke building. A lot of places will actually put sort of open source code, on their blog or link it to a GitHub account. So it's actually not that hard to find which data set they're using, figure out what statistical techniques they're trying to do. And it's a really, really great way to struggle through a problem, is to actually start with like the same sort of messy data set that professionals are starting with, and try to come up with some kind of product. So what I did is I took play-by-play data. This is sort of like play-by-play data that you can could download at the time from like Brian Burke's blog, and I'm sure there's still a source for it. And if anyone's super interested, I could probably send you this kind of play-by-play data that goes back to like 2001 season. So you have thousands of games that you can build sort of a model for how likely is the home team to win at any given like down distance situation within a game. And then that allows you to build something like this plot of like win probability throughout the game. This is actually for an NBA basketball game. But what I did is I started with play-by-play data. I parsed it to pull out the features that I would care about in my model. I tried a bunch of different models to figure out how exactly I wanted to specify this. How can I make the win probability graph look smoother? How can I deal with sort of differences at the end of the half and at the end of the game? How can I factor in, how many timeouts a team has, or how good we think a team is before the game started? So there's all of these questions, and it took me, sort of probably over like, months while I was still an undergraduate student, sort of like going through all of this. But it was super, super valuable for me, not only to figure out that like, hey, I am really interested in this, and this is like a fun thing that I really enjoy doing. But it also really just gave me something that I could always talk about in an interview as someone with no like data science background, where I could really describe like, hey, this is how I've actually gone through a real world problem where I was trying to create an output or answer a question, and I started with messy data, and this is what I was able to produce. So really creating that portfolio and doing some of that messy work is really important. So now I wanted to move on to just some like more general topics about data science interviews, because I thought this might be helpful. So if you look on LinkedIn, the skills that are listed most commonly for people with a data scientist job title, you see things like, you see a bunch of programming languages here, like, SQL, Hadoop, which is, probably just for like sort of big data machine learning engineers. And then like Python and R also sort of rank highly. So like if you looked at something like this, you'd be like, wow, I just need to learn a ton of different programming languages. But that's not necessarily the case. And it's certainly important to like know something like SQL or know either Python or R. But it's more important to really get that wide range of skills. So data science interviews can look really different depending on which company you're interviewing at. Here are, two companies that a colleague of mine interviewed at. So they both had pretty sort of like substantial like interview panels. But company X focused more on like actually having experience with SQL and like doing like a little bit of like decision sciencey type visualization and metric design, and like sort of feature analysis. So really thinking about like the like business impact that a data scientist might have, or a decision scientist might have. Company Y, like the job title might be exactly the same. It still might say data scientist, but this company might have you do like a full scale like analysis exercise where you're programming in a room for like 2 hours, trying to complete some kind of challenge. They might test like your like statistical modeling skills. They might have you do actual whiteboard coding to see sort of how much experience you have with programming. They'll ask you some like machine learning conceptual questions where you'll really want to have a good understanding of that topic. So there's a lot of different types of questions that you might be asked in a data science interview. So it's really good to work on that sort of broad base of skills, just so that you feel at least somewhat prepared for like all of these different things, because it's like honestly impossible to be like a superstar in like all at answering all of these different questions. So it's good to kind of get a broad base and understand how you might attack each of these. And then, you know, depending on where your real interests lie, that can be sort of like your differentiating factor. So this slide comes from my colleague again, who when she prepared for for data science interviews, a couple of resources that are good. Certainly, Coursera is a great resource, and we have a ton of data science material, which is why all of you are here, I'm hoping. Another great resource that she talked about is Leak Code, which allows you to like practice sort of whiteboard coding. So that can be really important, especially if you're interested in a more sort of data product type role. And really the goal, as I tried to talk about earlier, is really a T-shaped distribution of skills. So you want to have this breadth of knowledge where, you know, you're covering math, stats, and business, and in addition to programming and machine learning. So you sort of have some knowledge in all of those, and then you usually have sort of like a depth of expertise in one of them. So for me, I had a pretty good background in like statistics and statistical modeling. So, you know, doing sort of inference from statistical models was sort of my like depth of expertise. But, you know, someone else might be like, oh, I'm a really good programmer and I have a ton of experience with machine learning, and that's sort of your depth. Or I've worked with, you know, a bunch of A/B testing frameworks in the past, and I really understand how to analyze them quickly and, you know, drive business results. That could be in sort of another like depth of expertise. So it's good to kind of understand like your strengths and weaknesses. People coming from an engineering background probably don't need to work too much on their programming, but instead should really focus on the statistical inference and sort of like the business acumen. So, you know, try taking a problem where you're trying to really answer like a, you know, business decision. Like, you know, for me, it might be like, how important is, for me, looking at, you know, American football statistics, you know, one of the questions I tried to answer was like, which type of play is the best to run from on first down and goal to go situations. So like you have a very clear question that you might want to take to like a supervisor, in this case, like a, you know, football coach. And you try to use data to answer that. If you're coming from more of the math, statistics, science, economics background, it's really good to sort of like develop your programming instincts. So in this case, it's great to take on projects where, you know, you're having to clean a lot of data, or you're having to, you know, write, like, you know, create like an actual sort of product where, you know, everything has to sort of function right, and you're getting more experience with like optimizing code and, you know, making models run faster, et cetera. So try to choose sort of like practice problems that will help like develop your weaknesses. So some general tips for interviewing. The first tip is that interviews look super different across like companies and across roles within a company. So really focus on like preparing that like depth of expertise, but and do so in a way that is efficient based on sort of your priorities and your background. The second tip, which I highly endorse, is like really getting your hands dirty. So practice your skills on real data that's, you know, messy. You can find a lot of like Kaggle competitions that deal with like real data that you have to do a lot of cleaning. Like cleaning data is not, you know, always what you think about, you know, maybe from a high level for what a data scientist will do, but it is a super important thing, and it's going to really, you know, help you understand if this is like, you know, a job that you really want, and it'll help you sort of prove to employers that you're sort of capable. Um, and tip number 3 is really developing like your, you know, business savvy. So these aren't necessarily things that you can like take courses on, but having sort of like business intuition, looking at like case interview questions, like, you know, that a consultant might answer, is a really good idea. And really knowing like the company that you're interviewing for, knowing, you know, what their situation is as a business, and having some ideas about, you know, features that they might want to build or strategic decisions they might want to make, and how you might answer that with data is like a really good sort of exercise to go through. So sort of the last of the pre-submitted questions, sorry, I've been talking so endlessly, had to do with sort of like, hey, what are like important like suggestions, tips that I think it would have been good to know when I started with data science. So this was actually a super relevant question for me. Like I said, my role here was actually my first full-time data science job. So I came in like super junior, and I definitely had a lot to learn. When I first started as a data scientist, I really thought like, okay, like the thing I know how to do is like, you know, analyze data, and I should spend all my time like writing queries and writing code, you know, to like, you know, answer like the questions that I am given from like product managers or engineers or whoever. What I've learned is that it's obviously that is sort of like the specialized skill that a data scientist has, but it's actually really important to focus on like communicating your results. So this is not just true for a decision scientist, but also for someone who's focused on machine learning. As a data scientist, you know, you're really the one who understands like what the data is really capable of, and what, you know, type of product this data can power, and, you know, either the limits or the bounds of sort of what you can build. So it's really important to, you know, do things like write documentation for, you know, products you build. So I just put, you know, I have like a big long documentation, or a document about like an at-risk model that I've built, just so that I can then send that to people around the company to help explain like exactly how the product I've built works, and what are the applications that we have now, and what are the future applications. And then really building sort of like visualizations and tools that different people around the company can use, so that they can really understand the type of work that you're doing. The real way to like become a successful data scientist isn't necessarily like, oh, you know, I implemented this like awesome like modeling framework, and, you know, I was able to drive up, you know, my AUC by whatever, like, you know, 0.05, like that's the kind of stuff that you might read about in academic papers. But really what it comes down to is, can you have a big business impact on the company or the organization that you're working with? So focusing on not just doing your work, but also really communicating the results and taking the time to do that, and producing outputs that a lot of different people can understand is super paramount. The other thing I'd say that I wish I had known when I had first started as a data scientist is that do not be afraid to be a lifelong learner. Like, I've talked a lot about how data science is a really broad topic, and different data scientists have totally different sort of specialties and backgrounds. It's really important, like, as you're working as a data scientist, to continue to like develop the skills that you're like interested in developing. So one example for me is that I had sort of no background in like natural language processing when I started at Coursera, but I've always been interested in it. It seems really cool and powerful. So I was able to sort of propose a project where I wanted to analyze the like free text feedback that the Coursera platform sort of collects about different courses, and then turn that into sort of like an actionable product that we could send to our university partners, and that we could sort of use to understand our content better internally. I was able to sort of like propose this project to my manager, and and part of the steps for me there was to actually like take a Coursera class about natural language processing, partner with a teammate who had a background in it. So, she could help me understand how I should tackle the problem, and she could share some code snippets with me. And in that way, like, this project was really challenging for me, but is also super rewarding because I felt like I was learning a lot. I was doing something sort of fresh and new. And that's really one of the main benefits of being a data scientist, like continuing to learn new things. So definitely don't shy away from taking on new challenges. And, if you're not sort of taking on new types of projects and learning new skills sort of continuously, then you're more or less doing it wrong from my perspective. So the last sort of step that I never valued when I first started as a data scientist is like organization. In general, and this varies, I think, company to company, but data scientists have a lot of stakeholders that they work with. It's not, unless you're working at, someplace with like an enormous data science team where you might be focused on like one component of one product, you're going to have a lot of different types of projects that are simultaneously going on. So it's really important to like keep yourself organized and understand like, hey, where are my priorities, for this quarter, and which projects do I, absolutely want to get done. Taking the time to like really make project docs and understand, exactly what is the goal of your projects. And this is something you can even practice as you're, preparing for a data science interview or jobs, like when you're doing some of those like real world applications of data science, like actually think through this stuff, like think about like what you really want your output to be, like, what are your goals? What is the scope of your project? And like really staying organized is like a really good muscle to develop. And it's something that I did not do a good job of when I first started. And I would, constantly find myself like switching context between projects and not being as efficient as possible. But really taking a little time up front to like organize yourself is super, super important. Okay, cool. That is all I prepared for the pre-submitted questions. I see a couple additional questions that I'll try to get to now. So a question from Woodleya. The interpretation/communication of analysis to non-technical people is considered as an important part of a data scientist job, but there is not as much resource training. Can you think of recommendations, advice on this? Thank you. Yes, that is totally true. So specifically, like if I look at this slide here about all of the different types of projects that data scientists, or different types of skills that data scientists need. Some of this stuff, there are really good resources. Certainly programming, there are a ton of resources, not just Coursera, that can help you learn, in addition to like more traditional academic institutions. Math, statistics, kind of same thing. Machine learning, like, Andrew Ng's machine learning class is obviously, one of the best things that Coursera really has. But like this final bucket, which is like business product intuition, is definitely something where there are fewer online resources. But as you can see sort of from these like interview questions, it is something that is like typically talked about, like website feature analysis and hypothesis generation. So there are two sort of main pieces of advice that I might have for like developing this acumen. The first is when doing like a real world sort of like data analysis project and like, deciding sort of what you want to work on. Like for me, it was always sort of sports analytics, but, there's certainly a ton of other, really interesting data sets that are sort of out there that you might want to ask questions about. I would really try to target a project where there is like some sort of strategic question that is at stake. So try to think about this perspective from some, organization, and what like a real product decision maker might be trying to think about. like if I was in charge of an airline, how might I think about pricing uh, seats on like different aircrafts? Or if I was I'm trying to think of non-sports examples. If I was a policymaker, how might I think about, or if I was a politician, how might I, spend some allotment of funds on my campaign trail? Like, where should I target my campaign based on like, survey results data? So really thinking about the companies that you're interested in, especially, or like just in general sort of companies, like what are the business problems that they might be thinking of, and then trying to answer those with data is a really good step. And I'd say that also, like, it's easy to sort of like run your analysis and then know in your head, like, oh, okay, like this is how I would do my pricing strategy if I was running, an airline. But actually being able to put that into words, put that into like sort of a blog post form, or put it into like a Python notebook or markdown file form, where you're not just showing like a standalone graph, or even worse, just showing like standalone numbers, but really being able to describe like exactly what's going on, and maybe send that to other people in your network who can help you understand, like, whether like, oh yeah, like I totally understand what the type of analysis you did is. Maybe I don't know all the details, but I really am buying into like the conclusions that you came to. So that's the kind of thing that you really want um, uh, to practice. Yeah. So to sum up that first tip, I'd say like when you're doing sort of like building out your portfolio, I would focus on real world like business problems, and I would focus on actually creating an output that communicates the results to a business person or a lay person, or at least someone who is not going to understand your code. The second sort of like guiding tip that I would have is like, especially like before interviews where like a specific company where you're interested in a role, I would spend a lot of time like actually thinking about it from a like product manager's perspective. And what you can do is actually look up like product manager interview questions. And certainly some of those aren't going to be relevant, but anything about like, understanding like the big challenges that a company is facing, and thinking about like how you might try to answer some of those questions with data is like just a super, super good exercise to do. Before I like interviewed at Coursera, I actually thought about, okay, what are probably like the big issues that they're thinking about? Certainly there's something about like, how do we get more learners on the platform? There's probably something about how do we get more learners who enroll in courses to complete them? How do we, understand like which courses are more difficult or easy? And from that, we're able to, from all of those, going through all of those, types of questions, you can really get like be sort of prepared for the types of interview questions that you might get. So yes, it's much harder to sort of develop those skills than other types of more like established skills, but it's again just about practicing and like developing that muscle. Okay, cool. I see one other question. Do you think being an older worker adds another layer of difficulty to transitioning into a data science career? I've always been a lifelong learner and have been taking online data science courses for 2 years, but I've read so much about older workers being rejected because of a bad cultural fit that I dread going out there for interviews. Yeah, this is a really good question. I can't speak from experience too much, but I will say that in general, I think data science has like some of the most like diverse and different backgrounds of any type of career. And I can't speak to how all companies hire, but like at Coursera, we're very focused on actually hiring people for the like competencies and like skills that they've really developed. Certainly, I think like when someone has a less traditional background, we look for like, you know, if someone has a PhD in economics, it's like pretty clear that they probably have some experience with this kind of stuff. They have that signal, but not all of us have that. You know, I only have an undergraduate degree. So I was more focused on like building a portfolio of projects, real world projects that I had worked on. And that's sort of was my way to try to get a career like that. My advice would be like, certainly I don't, you know, not all places are going to sort of discriminate based on like having a more non-traditional path towards being a data scientist. But if you are sort of lacking in some of the more traditional signals, just the way that our economy is structured now, I would focus on really developing, you know, that portfolio and showing that like, hey, like you want someone who can do this kind of work? Look, I've done it. I took a real like messy data set. I decided what questions I wanted to answer. I went through the analysis, or I, you know, built a model to do X, Y, Z, and then I put my results sort of in this blog form. It's like I would hope that it's less sort of like, you know, discrimination that's going on, and more just sort of like the lack of signaling that makes it harder for you know, different employers to you know, decide that someone from a less traditional background is a good fit. But the way to really counteract that is to you know, develop your portfolio and practice some of like the, you know, practical you know, actual like data science skills. So then you can showcase, and you know, there's no way they can really you know, not take that at its face value. But great question.